परसों ही है ना, मुझे कल ही बनाना पड़ेगा। मैं इंशाल्लाह ताला कल सुबह ही बनाती हूँ। हाँ, ओके, थैंक यू। अल्लाह हाफ़िज़। Yes, good afternoon, students. Uh, Today we'll start with the data structure. In this today's lecture, we'll study Q data structure. So Professor Abdul Razak has already taught you two things in or two data structures, arrays and stacks. We'll start with Q data structure. So first of all, what is data structure? So data structure usually deals with data. So how to use data, how to store data, how to process the data, how to gain knowledge from it, and how to keep it secret. So these are the things which we can perform on data. Like first of all, we use the data. For using it, we store the data. Again, for using it, like for gaining something from it, we process the data. After processing the data, we get some knowledge from it, and then we see how to keep it secret. Out of all these things, data structure deals with how to store it and how to process it. So this we are going to discuss here. So data may be a single value or it may be a set of values. For processing, it must be organized in a particular fashion. This organization leads to structuring of data. So the exact definition of data structure is it is representation of the logical relationship existing between the individual elements of data. Or we can also state it as it is a way of organizing all data items that considers not only the elements stored but also their relationship to each other. It is also defined as a mathematical or logical model of particular organization of data items. So eventually, whatever definitions we are discussing here, it is the relationship amongst the data between the individual elements of data. So we have to take care of the representation, how we are going to represent it logically, or what is the relationship between the individual elements. We have to take care of that in data structure. Or we can also say that it is a way of organizing all data items that considers not only the elements stored but also their relationship to each other. Now, there are various types of data structures. Out of them, some are listed here. So, the elementary data structures are arrays is the first elementary data structure. Then, linked list is there, stacks, queues, and tree data structure is there. Apart from this, we are having uh, s- these are the elementary or you can say the primary data structures. We are having secondary data structure as well. So In some languages, these are the basic data types. We don't have to implement them separately, but in some languages, we have to implement these data structures separately. If we are talking about C language, so we have to implement these data structures. So here we are going to discuss Q data structure in detail. So what is a queue? So queue is a collection of elements. Here in queue, the elements are added at one end. That is it is also called it is called as rear, or it is also called as tail of the queue, and removed from the other end, which is called as the front or head of the queue. So this is very important. Like insertion and deletion cannot be done from same end. So a queue is having two ends, rear end and front end. So insertion is possible from rear end, whereas deletion is possible from front end. So basically queue is a linear data structure, while stacks allow insertion and deletion of data only at one end. Queues restrict the insertion and deletion of data at two distinct ends, at two different ends. Just like stacks, queues also hold great significance in the implementation of the key system processes such as CPU scheduling, resource sharing, etc. So a queue is a FIFO data structure. FIFO means first in, first out. So here, whatever data is getting stored first will be deleted first. Inserted first will be deleted first. So queue is a FIFO data structure, that is first in, first out. So queue is a linear data structure in which items are inserted at one end called rear or tail and deleted from the other end called front or head. Queues are based on the first in first out principle. That means the data item that is inserted first in the queue is also the first one to be removed from the queue. We can relate queues to certain real life objects or situations. For example, any waiting line is a queue. The checkout line at a grocery store, or the cars at a stoplight, an assembly line. So these are the various examples, real life examples, which is equivalent to the concept of queue. So this is the conceptual view of a queue. So here you can see we are having two ends, front end and rear end. So the person who's standing first will be removed first from the queue. So that is the front of the queue, or the deletion of the element can be done from the front end, while insertion can be done from the rear end. So here in this diagram also you can see new element is added to the rear of the queue, and the element is removed from the front end of the queue. Now, if we elaborate some example, so a person can join a queue of waiting people only at its tail end or rear end, while the person who joined the queue first becomes the first one to leave the queue. Likewise, the objects in an assembly line also follow the same analogy. A new object cannot be added at the middle of an assembly line. Another example of queue is the line up of vehicles at the toll booth. The vehicle that comes first to the toll booth leaves the booth first, while the vehicle that comes last leaves at the last position. Thus, observing the FIFO principle, that is the first in, first out. The concept of queue in data structures follows the same analogy as the queue of people or the queue of vehicles at toll booth. So that's what we had already discussed here, that any waiting line is a queue, because whoever is going to come first in the line will be removed first from the line. So it is first in, first out. Now, the logical representation of queue. How exactly we are going to implement it in memory. So, just like their real world counterparts, queues appear as a group of elements stored at a contiguous locations in memory. We can say array. In array also, we are having contiguous allocations of memory location. So here also in queue, we are having contiguous allocation of memory location. Each successive insert operation adds an element at the rear end of the queue, while each delete operation removes an element from the front end of the queue. So here you can see, if I want to insert, like already HELLO is inserted. If I want to insert some another character, it will be inserted from the rear end. So rear end will be incremented first, that is rear is equals to rear plus 1. So in our situation it is 4 is equals to 4 plus 1, that is rear is equals to 4 plus 1, that is 5. So at fifth position new element will be inserted, and if I want to delete some element, so I have to move the front position. So front is equals to front plus 1. So 0 plus 1, 1. So H will be removed. So deletion is possible from front end, while addition or insertion is possible from rear end. The location of the front and rear ends are marked by two distinct pointers called front and rear pointers. So these two pointers are called as front and rear pointers. Now in the figure we can see the logical representation of Q in memory. There are 5 elements in the queue with H at the front and O at the rear. Now the various queue operations, here you can see, as I have said, after inserting an element in queue. So it is after O, because that is the only location which is empty, or insertion is possible at rear end only. So here in this rear end we can do the insertion thing. Now if I want to delete, deletion is possible from front end only. So here you can see that the element is deleted from the front end. So it is simply front is equals to front plus 1. Now the queue operations. So there are two operations which we can perform here, that is insertion and deletion. So these are the two key operations which are associated with the queue data structure, insert and delete. The insert operation adds an element at the rear end of the queue, while the delete operation removes an element from the front end of the queue. So this insertion is called as NQ and deletion is called as DQ. Entering the data in the queue is NQ, that is add an element to the tail or rear end of a queue, and DQ, that is delete element from queue or remove an element from the head or front of a queue. Apart from that, uh, we can have one more operation, that is first, which will always tell us which is the first element in the queue, or which is the element which is pointing by front pointer, that is the first operation first. Now next is queue implementation. So queue implementations involves choosing the data storage mechanism for storing queue elements and implementing methods for performing the two queue operations, insert and delete. So here, while implementing the queue, we have to decide the data structure or the data storage mechanism which we are going to use. So there are two method of queue implementation. One is static implementation and another one is dynamic implementation. So static implementation is done using array data structure, and dynamic implementation is done using linked list implementation. Linked list implementation or linked list data structure. Uh, Array implementation has several disadvantages. We'll discuss these disadvantages later on. However, both types of implementation have their usage in specific situation. Like at some part or at some situation, we can only use array as a data structure for implementing queue, or in some situation, we can use linked list as a data structure for implementation of queue. So it depends upon the situation, in which situation we are going to use which type of data structure, array or linked list, that is static implementation or dynamic implementation. Now, algorithm for inserting an element in queue. The insert operation involves checking whether or not the queue pointer rear. We're having two pointers, rear and front pointer. Now, insertion is done through rear pointer. So the insert operation involves checking whether or not the queue pointer rear is pointing at the upper bound of the array. Okay, we are discussing array implementation here, that is static implementation. So the array implementation of queues involves allocation of fixed size array in the memory. Both queue operations, insert and delete, are performed on this array with a constant check being made to ensure that the array does not go out of bounds. Okay, so here we had written max, so that is the maximum size of the array which is already defined. We have to be in this limit only. Whatever insertion or deletion operations we are going to perform, we have to perform it in this limit only. So we have to check the bounds every time while performing insertion operation and deletion operation. We have to see the bounds or the limits of the array. So while doing the insertion operation, we have to check whether or not the queue pointer rear is pointing at the upper bound of the array. If it is not, rear is incremented by 1 and the new item is added at the end of the queue. So same is written here. If rear is equals to max minus 1, this means the queue is overflow. So we cannot insert the element here. If front is equals to minus 1 and rear is equals to minus 1, so this is the initial situation, that initially when there's no element in your queue, when there's no data item in your queue, so your front and rear, both the pointers are pointing towards minus 1. Because in C usually we start allocating data, or we start allocating data from 0th location. So if the size of your array is 5, that means you can use it from 0th location to 4th location. But when in the initial condition, when there's no data in the queue, so front and rear both are going to point to minus 1. Since we are starting from 0, so they are pointing to minus 1. So if there's no element, if the queue is empty, so the first element will become the whatever element we are going to enter will become the first element. So if front is equals to minus 1 and rear is equals to minus 1, this means if the queue is empty, set front is equals to rear is equals to 0. Means right now front and rear both the pointers are pointing towards the first element, that is the 0th location. This case is for first element. The first step 1 is for checking whether the queue is empty or there's space in the queue for inserting data. If the queue is empty, then the step 2 for if part is there. If for example we are entering second element in the queue, then front is not equals to minus 1 and rear is also not equals to minus 1. So we'll go to else part and set rear is equals to rear plus 1. Now at this place of rear, we are going to insert the data. So set q of rear is equals to num. So initially rear was minus 1. After entering first data, rear became 0. Now for inserting second element, rear will become 1. It will point to the first location of the array. So we are going to insert the data there. So in this way, insertion operation is possible in queue. Next is delete operation, or algorithm for deleting an element in queue. So the delete operation involves checking whether or not the queue pointer point sorry the delete operation involves checking whether or not the queue pointer front is already pointing at null, that is empty queue. If the queue is empty, we cannot delete data from the queue. So that's why first, while deleting the data, first we have to see whether the front is pointing towards something or front is pointing to null. If it is not, the item that is being currently pointed is removed from the queue and the front pointer is incremented by 1. So this is the only step we have to perform, that front is equals to front plus 1, then deletion. That means the first item is deleted. So step 1 is, if front is equals to minus 1 or front is greater than rear, write underflow. This means that data deletion is not possible. If this is not the condition, then set value is equals to q of front. Whatever the data is there, it is copied in value variable. And now front pointer is set to front plus 1. So in this way, data is deleted from the queue. Now, the drawback of array implementation. So, the drawback of array implementation is memory wastage. So, how the memory is wasted? So, here you can see in the diagram, total we are having 10 locations for storing data, or the size of the queue is 10. It is starting from the location 0 to location 9. We have inserted some elements here at 0th location, at first location, at second, third, fourth, fifth, sixth, seventh. So that's since the data is up to 7th location, rear pointer is pointing towards the 7th location, and front pointer is pointing towards the 5th location because we have already deleted the first 5 items. Now, if I want to insert data, for example, it is 40. So it is possible at this location. I can insert data here. After that, if I want to insert 50, I can insert it here. Now, if I want to insert data 60, I cannot insert it. Still, locations are empty, but still I cannot insert it because once we had left that place, if the front pointer is moved further, we cannot take back the front pointer. So here the memory is wasted. So the space of the array, which is used to store queue elements, can never be reused to store the elements of that queue because the elements can only be inserted at front end and the value of front might be so high so that all the space before that can never be filled. So that's why the memory is wasted here. So there is the second type of implementation, that is dynamic implementation or linked list implementation of queue. The storage requirement of linked representation of a queue with n elements is O of n, while the time requirement for operations is O of n. If we are having n elements, if we want to store n elements, then the complexity will be O of n, and the time requirement for each operation, that is insertion and deletion, is O of 1. In a linked queue, each node of queue consists of two parts, that is the data part and the link part. Each element of the queue points to its immediate next element in the memory. So here in the diagram, you can see this is the first node, which is having data 9. So this is the data part, and second is the link part, which is pointing towards the next element. In the next element, link part, the last node is where the rear pointer is pointing, because if now we want to insert data, we have to add it after rear, like after this last location we can insert. So these are the two pointers, front and rear pointer. Now, the linked implementation of queues involves dynamically allocating memory space at runtime while performing queue operations. As this is the difference between the static implementation and dynamic implementation. Like in static, the memory is allocated at execution time, while in dynamic, the memory is allocated at runtime. So there's no limitation. Since the allocation of memory space is dynamic, the queue consumes only that much amount of space as is required for holding its data elements. This is contrary to array implemented queues, which continue to occupy fixed memory space even if there are no elements present. Like, for example, if this is the example, like we are having 10 elements, and if we don't have data to store in the queue, still the memory will be allocated and no data is stored. Whereas in linked representation, if there's no data, we don't we won't assign memory for it. If we are in need of storing data, we'll assign locations at the time of that when we are in need of storing the data. So this is the difference between the dynamic and static allocation. In dynamic memory allocation, it prevents wastage of memory space. Now, how insertion is done in linked list. So first, reserving memory space of the size of a queue element in memory. whatever data we want to store, if we want to store integer, if we want to store character, or you want to store a real number. So depending upon that, whatever the requirement of the memory is there, so first of all we have to reserve the memory space in memory, then storing the added value at or inserted value at the new location. So first we have to store that data in that new location, then linking the new element with the existing queue. Whatever the new data is there which we have inserted, so now we have to link it with the existing queue. And finally we have to update the rear pointer. So these many steps are written here in this algorithm. First, step 1 is allocate the space for the new node. For example, it is PTR. Set PTR of data is equals to value. So we have to store the data. Now, if front is equals to null, this means there's no data or there's no link queue right now. So set front is equals to rear is equals to PTR. If this element will become the first element, then front pointer and rear pointer both will point to the same element. So front is equals to rear is equals to PTR. If this is not the case, if this is the second element, for example, set front of next is equals to rear of next is equals to sorry, we have to store null here because this is the only first element. So front of next is equals to and rear of next is equals to null. Both the pointers are pointing towards null. If we want to insert the second element, then we'll go to else part. Set rear of next is equals to ptr, set rear is equals to ptr. अब हमने जो ptr pointer है उसको आगे बढ़ा दिया. Now front is pointing at the first location and rear is pointing at the second location, or the second data which we are having in a queue. Now set rear of next is equals to null. So in this way, elements are getting inserted in queue, but the implementation is done using linked list. Now next is deletion. So algorithm for deleting an element in queue. So while deleting also we have to perform 4 steps. First is checking whether the queue is empty. If queue is not empty, then only deletion is possible. Then retrieving the frontmost element of the queue, we have to retrieve the front element, then updating the front pointer, and finally returning the retrieved or removed value. So if front is equals to null, this means no deletion is possible. Queue is underflow. If front is not equals to null, then set ptr is equals to front, set front is equals to front of next. So front is equals to front of next means हमने front pointer को आगे बढ़ा दिया है, whereas ptr pointer is pointing towards the previous front. Now free ptr. So here in dynamic memory allocation, this step is very important. If we want to delete the data, we have to free the memory location. So free ptr is very important step. So here there's no wastage of memory. Now again we can use that memory location for inserting element. So free step is very important in dynamic memory allocation while deleting the data. Now all the insertion and deletion process or insertions are called as NQ while deletions are called as DQ. This is very important, NQ and DQ operation. Now next is the next type of queue, that is circular queue. Why was the concept of the circular queue introduced? There was one limitation in the array implementation of queue. Right now we had discussed that memory is wasted here. Once the element is deleted from the location, now we cannot insert another element at that particular location. So that memory is wasted. So to avoid that memory wastage, we have implemented circular queue. So if the rear reaches to the end position of the queue, then there might be possibility that some vacant spaces are left in the beginning which cannot be utilized. So to overcome such limitations, the concept of the circular queue was introduced. Here you can see the first 3 elements, the first 3 locations are empty. We can store data there, but since the front pointer is pointing towards the third location, we cannot insert the data there. That memory is wasted. So to avoid that memory wasted, we can have circular queue. Now, this circular queue is circular in logic. Logically, it is circular, but actually, it is contiguous memory allocations only. But here, we are going to store the data in such a way that we will assume of it will be in, we'll assume it as circular. A circular queue is a queue whose start and end locations are logically connected with each other. That means the start location comes after the end location. So here you can see this is the end location. After this, the start location is coming. So your start location comes after the end location. If we continue to add elements in a circular queue till its end location, then after the end location has been filled, the next element will be added at the beginning of the queue if the location is empty. So if the location is empty, we can insert data here. In circular manner, we can use all the locations here. So here memory is not wasted. Circular queues remove one of the main disadvantages of array implemented queues in which a lot of memory space is wasted due to inefficient utilization. As we can see in the figure, the start location of the queue comes after the end location. Thus, if the queue is filled till its capacity, that is the end of the location, then the start location will be checked for space, and if it is empty, the new element will be added here. A circular queue is similar to a linear queue as it is also based on the FIFO, that is first in first out principle, except that the last position is connected to the first position in a circular queue that forms a circle. It is also known as a ring buffer. The following are the operations that can be performed on a circular queue. We're having two pointers, front pointer and rear pointer, NQ and DQ. Like NQ means insertion of elements and DQ means deletion of elements. Now, NQ operation. The steps of NQ operation are given below. First, we will check whether the queue is full or not. Initially, the front and rear are set to -1 when the queue is empty. When we insert the first element in a queue, front and rear both are set to 0. When we insert a new element, the rear gets incremented, that is rear is equals to rear plus 1. There are two scenarios in which queue is not full and we can perform the insertion operation. So for that, the first condition is if rear is not equals to max minus 1, then rear will be incremented to mod of max size and the new value will be inserted at the rear end of the queue. We have to see this condition. We have to check this condition. If this condition is true, then only we can insert the element. Second condition is if front is not equals to 0 and rear is equals to max minus 1, it means that queue is not full. Then set the value of rear to 0 and insert the new element here. Now, deletion is also, these are the two cases in which the element cannot be inserted. When front is equals to 0 and rear is equals to max minus 1, which means that front is at the first position of the queue and rear is at the last position of the queue. So here data insertion is not possible. And if front is equals to rear plus 1, in this case also data insertion is not possible. Now algorithm to insert an element in a circular queue. If rear plus 1 mod max is equals to front, this means overflow. So this is the condition we have to check whether the queue is full or is there any space left. So if rear plus 1 mod max is equals to front, this means overflow. We cannot insert data here. If front is equals to -1 and rear is equals to -1 means that the queue is empty. So set front is equals to rear is equals to 0. Else, if rear is equals to max -1 and front is not equals to 0, set rear is equals to 0. This is the second condition. And third is set rear is equals to rear plus 1 mod max. So in this way, we can assign the value of rear or we can decide the value of rear. Once the value of rear is decided and it is allocated to rear, now we can insert the data. Now next is the DQ operation. The steps of DQ operations are given below. First, we check whether the queue is empty or not. If the queue is empty, we cannot perform the DQ operation. When the element is deleted, the value of front gets decremented by 1. If there is only one element left which is to be deleted, the front and rear are reset to -1. If front is equals to -1, this means deletion is not possible. First of all, copy the value of front to the value variable. If front is equals to rear, this means there's only one element in the queue. And after deletion, front is equals to rear is equals to -1. Now the queue is empty. If this is not the case, if front is equals to max -1, set front is equals to 0. Else set front is equals to front plus 1. In this way, elements can be deleted from the circular queue. Now there's one more type of queue which is called as DQ, that is double-ended queue. The DQ stands for double-ended queue. In the queue, the insertion takes place from one end while the deletion takes place from another end. But in DQ, insertion and deletion is possible from both the ends. Here also we'll be having front end and rear end, but insertion and deletion both is possible from both the ends. A double-ended queue is basically a special type of queue that allows insertion and deletion of elements at both ends, that is front and rear. In simple words, a double-ended queue can be referred as a linear list of elements in which insertion and deletion of elements take place at its two ends but not in the middle. This means we can either, here with the arrow you can see, we can either insert or delete the element from both the ends, but we cannot insert or delete the elements in the middle. In which so DQ is a linear data structure in which the insertion and deletion operations are performed from both ends. We can say that DQ is a generalized version of the queue. There are two types of queues: input restricted queue and output restricted queue. So what exactly is input restricted queue? Here insertion is possible at one end where deletion is possible from both the ends. That is called as input restricted queue. The input restricted queue means that some restrictions are applied to the insertion. The insertion is applied to one end while the deletion is applied from both the ends. We're having output restricted queue. So in the output restricted queue, the restrictions are applied to the deletion operation. Deletion is possible from one end while insertion is possible from both the ends. That is output restricted queue. In an output restricted queue, the deletion can be applied only from one end, whereas the insertion is possible from both ends. Now, what are the operations which we can perform? So, following are the operations: insert at front, delete from front, insert at rear, and delete from rear. So, insertion up till now, we have seen that deletion is possible from front and insertion is possible from rear. Now, in this case, double-ended queue, insertion and deletion both is possible at both the ends, front end as well as rear end. Now, the last type of queue is the priority queue. A priority queue is an abstract data type that behaves similarly to the normal queue, except that each element has some priority. That is, the element with the highest priority would come first in a priority queue. So here in this priority queue, each element is assigned certain priority such that the order of deletion of elements is decided by their associated priorities. We cannot delete the elements randomly. We can delete the elements only according to their priority. The element which is having highest priority, we can delete that element first. It depends on the type of queue, type of priority queue, because we are having different types of priority queues. So we'll see that. So the priority of the elements in a priority queue will determine the order in which elements are removed from the priority queue. So the priority is given to the data, and depending upon this priority, only deletion is possible. Insertion can be done in any way, but deletion can be done according to the priority. The priority queue supports only comparable elements, which means that the elements are either arranged in an ascending or descending order. Now, the characteristics of a priority queue. A priority queue is an extension of a queue that contains the following characteristics. So, it is a normal queue, but it is having certain characteristics, extra characteristics in it. So, every element in a priority queue has some priority associated with it. That is the one point. Normal queue or priority queue में यही difference है that in normal queue we don't have priority associated with data. Here in priority queue, every data or every element will have some priority associated with it. An element with the higher priority will be deleted before the deletion of the lesser priority. So here priority is important for deletion of element. The element which is having higher priority will be deleted first. If two elements in a priority queue have the same priority, they will be arranged using the FIFO principle. First in, first out. The element which is inserted first will be deleted first. If two elements are having same priority, so the element which is inserted first will be deleted first. Now there are two types of priority queues: ascending order priority queue and descending order priority queue. Now, what is ascending order? In ascending order priority queue, a lower priority number is given as a higher priority in a priority. For example, we take the numbers from 1 to 5 arranged in an ascending order like 1, 2, 3, 4, 5. Therefore, the smallest number, that is 1, will be having highest priority. This is ascending order priority queue. Next is descending order priority queue. Here, a higher priority number is given as a higher priority in a priority. For example, in descending order, we are having numbers 5, 4, 3, 2, 1. So 5 will be given the highest priority. So this is the descending order priority queue, and this is the ascending order priority queue. So these are the various types of queues which we are having. We are having a normal queue which is implemented either using array or using linked list. We have seen that. Then we are having we had discussed circular queue because the queue which is implemented using arrays having drawback of memory wastage, so we can have circular queue. Then we have double-ended queue, that insertion and deletion is possible from both the ends. And then we are having priority queues. Here the priority is associated with each and every data, and data is deleted according to the priority. So these are the different types of queues. Now next we are going to discuss the questions which are asked in gate papers in the uh, years, like previous years. So first question is, if the array representation of a circular queue contains only one element. If the array representation of a circular queue contains only one element. The question is asking us that it is an array representation of a circular queue and it contains only one element. Then which option is true? Front is equals to rear, front is equals to rear plus 1. Front is equals to rear plus 1 means that it is having the array, the circular queue is having two elements. Front is equals to rear minus 1. This also means that there are more than one element. Front is equals to rear is equals to null means that there's no element in the queue. The queue is empty. Whereas the question is circular queue contains only one element. Then the answer is front is equals to rear. Then only we can say that we are having only one element in circular queue. The next question is, the process of accessing the data stored in a tape is similar to manipulating data on a stack, list, queue, or heap. The process of accessing the data stored in a tape. Tape is a magnetic tape. Here, data is stored sequentially. So, the accessing will also be done sequentially. So, it is similar to manipulating data on a queue? So the answer is Q. Next question is, among the following, which one is not the right operation on DQ? So first is DQ is the double-ended queue. So we have to see which operation is not the right operation on double-ended queue. So inserting an element in the middle of a double-ended queue, so that is not possible. Right now we had discussed that insertion and deletion is possible from both the ends, but it is not possible in the middle of a DQ. So up till now this option is correct. Next option is inserting an element in the front of a double-ended queue. That this is possible. This is the right operation. Inserting an element in the rear of a double-ended queue. This is also possible. None of the above. This option is wrong because the second and the third option is correct option. Like this is the operation which is allowed. So the question is, among the following, which one is not the right operation on a double-ended queue? So the answer is the first option, that is inserting an element in the middle of a double-ended queue. So the solution is the first option, that is inserting an element in the middle of a double-ended queue. Next question is, suppose a circular queue of capacity n minus 1 elements is implemented with an array of n elements. So the size of the array is n. Capacity of the queue is n minus 1 because it will start from 0. And the queue is circular queue. So it is a circular queue implemented using array. Assume that the insertion and deletion operations are carried out using rear and front as array index variables respectively. So insertion is possible at rear end and deletion is possible using front end. Initially, rear is equals to front is equals to 0. This means that we're having only one element here in the circular queue. The conditions to detect queue full and queue empty are. So we have to see the conditions and we have to identify which are the correct conditions to detect queue is full and queue is empty. So the first condition is rear plus 1 mod n is equals to front for full, and for empty the condition is rear is equals to front. So in this situation the first option is the correct option. This is the condition with which we can check the circular queue is empty or the circular queue is full. So the correct option is the first option. This is the explanation for that. It is basically the implementation of circular queue. The head is the front pointer and the tail is the rear pointer. So head, it always points to the location from where next deletion takes place from the queue, and the tail pointer is basically it always points to the next empty location in which the next insertion will take place in the queue. So here we have to see the wraparound condition. The wraparound condition is checked. The wraparound condition is checked uh, whether the queue is full or whether the queue is empty or not. So that wraparound condition is rear plus 1 mod n. This will give us the wraparound condition. So we have to see the wraparound condition. We have to check that wraparound condition, and with that we can conclude whether the queue is empty or queue is full. Next is a circular queue has been implemented using a singly linked list. A circular queue has been implemented using a singly linked list where each node consists of a value and a single pointer pointing to the next node. We maintain exactly two external pointers, front and rear, pointing to the front node and the rear node of the queue. Which of the following statements is or are correct for such a circular queue so that insertion and deletion operations can be performed in O of one time? So it is a circular queue implemented using linked list, singly linked list. There are two pointers, front and rear pointer, Now we have to see the options and we have to tell which one is the correct option for insertion and deletion operation which can be performed in O of one time. Next pointer of front node points to the rear node. Next pointer of the front node points to the rear node. And second is next pointer of the rear node points to the front node. So next pointer of rear node points to the front node. This is the correct option because it is a circular queue. So always the front rear is going to point towards the front. So that is next pointer of rear node points to the front node. While implementing circular queue using linked list, rear pointer always points front as it is done always for every new insertion. Front node next pointer points to rear only when there are only two elements in a queue. Insertion and deletion can be done in O of one time. Hence, the correct option is B. A queue is implemented using a non-circular singly linked list. The queue has a head pointer and a tail pointer. So the question asks, a queue is implemented using a non-circular singly linked list. Means it is a plain queue. The queue has a head pointer and a tail pointer. Let n denote the number of nodes in the queue. Let nq be implemented by inserting a new node at the head, and dq be implemented by deletion of a node from the tail. The operations are what we can say exchanged. Insertion is possible from, that is nq is possible from rear and dq is possible from tail. So here they had swapped the operations. Nq is implemented by inserting a new node at the head and dq is implemented by deletion of a node from the tail. Which one of the following is the time complexity of the most time efficient implementation of nq and dq respectively for this data structure? So we have to tell the time complexity for both the operations of NQ and DQ. Here we have to take care that NQ, both the operations are swapped. Usually NQ is performed from tail end, but here NQ is performed at head end and DQ is performed from tail end. So the options are, for NQ the time complexity is theta 1, for DQ the time complexity is theta 1. Again, option B, for NQ, the time complexity is theta 1. For DQ, the time complexity is theta of n. Option C, theta of n for NQ and theta of 1 for DQ. And option D, theta of n for NQ and theta of n for DQ. Now, which one is the correct option? The question is, which one of the following is the time complexity of the most time efficient implementation of NQ and DQ respectively? So, the correct option is B, NQ operations time complexity is theta 1, theta of 1, and DQ operations time complexity is theta of n. Why? Because we are performing NQ at the front of the node. So in one step, we are inserting the element. For performing DQ, we have to visit the n nodes, because here it is given in the question, let n denote the number of nodes in the queue. So if we want to delete the data, we have to delete it from the tail in this situation. So for deleting, first we have to visit the n nodes. So how many operations we are performing here? N operations. So complexity will be theta of n. So the correct option is theta of 1 for nq and theta of n for dq. So here again the explanation is given to us. As the NQ operation is done at header of linked list, it will take theta of 1 time. DQ takes theta of n time as tail points last node of linked list. After deletion, it takes n computations for performing deletion, it takes n computations to reach the last node. Hence, the complexity is theta of n for deletion operation or DQ operation. Hence, the correct option is B. Now next is, how many stacks are needed to implement a queue? If we have to implement a queue, how many stacks are needed for implementing that? Consider the situation where no other data structure like arrays or linked list is available to you. So it is compulsory that we have to implement queue using stack. Now stack is having only one end. Insertion and deletion both is allowed from that single end. But for implementing queue, we are in need of two ends. Implementation will be done from one end and deletion will be done from another end. So for implementing a single queue, if we are implementing it using stack, we are in need of two stacks for implementing that single queue, because we are in need of two ends and stack is having only one end. That's why we require here two stacks for implementing. Next question is, which of the following is true about linked list implementation of queue? So in push operation, if new nodes are inserted at the beginning of linked list, then in pop operation, nodes must be removed from end. Which of the following is true about linked list implementation of queue? So here, no doubt we are performing insertion and deletion, but it is written as push and pop. So push is for insertion and pop is for deletion. So in push operation, if new nodes are inserted at the beginning of linked list, then in pop operation, nodes must be removed from end. This is true. The second condition is in push operation, if new nodes are inserted at the end, then in pop operation, nodes must be removed from the beginning. This is also true. That's why both of the above option, that is the option C, is correct. Both the operations are possible. If we are performing push, that is if we are doing insertion at front end, then we can do the deletion thing from tail end or the rear end. If we are performing push operation at the end, that is at rear end, then we'll perform the pop operation from the front end. So both the conditions are possible. So the correct option is both of the above. Let's consider the following operation along with NQ and DQ operations on Q, where K is a global parameter. So one code is given to us, multi DQ Q, M is equals to K. K is a global parameter while Q is not empty and M is greater than 0. DQ of Q, M is equals to M minus 1. So basically this is deletion operation. But in that, the condition is given to us, Q is not empty and M is greater than 0. What is the worst case time complexity of a sequence of n multi-DQ operations on an initially empty Q? So worst case time complexity will be option A, that is theta of n, because we have to perform n sequences. So the complexity will be theta of n. Since the Q is empty initially, the condition of while loop never becomes true, so the time complexity is theta of n. Here you can see it is given that the multi-DQ operations on an initially empty Q. So if the Q is empty, but the condition is Q is not empty, so whenever we are going to try to perform this operation, the condition will never be satisfied and it will always be out of the while loop. So the complexity is theta of n. If we'll go inside the while loop, then we can say the complexity will increase. But right now, since we are not performing any operation, we are not performing any steps in the while loop, so the complexity is theta of n. So this much is there in linked list, sorry, Q. These are the questions which were asked in Q in the gate exam. So in next lecture, we'll discuss linked list. Thank you all of you.